Hello, everyone. On behalf of B&W Software, I would like to welcome you to today's webinar entitled Consistent Process Chain from Article to Finished Electrode. At first, I'd like to introduce ourselves briefly. My name is Christian. I'm a developer at B&W Software and will be moderating this webinar today. As our today's referent, I've brought along my esteemed colleague Florian. He's the main person responsible for Smart Electrode and our number one when it comes to electrodes. But before we start, I'd like to give you some more information. This webinar will be recorded and later on be available on YouTube. The link will be sent to you by email. At first, Florian will start with a topic-related presentation and then goes on with a live demo. Finally, there will be a short Q&A session. Questions and generally may also be asked during the presentation. Please use the question function provided for this purpose. If we cannot answer all questions during the webinar, we will be happy to contact you by email. And now it's your turn, Florian.
Hello, and thank you, Christian, for the short introduction. Well, welcome also from my side to the presentation, Consistent Process Chain from Article to Finished Electrode. About the topics. At first, we would like to start with a short survey to get some information about your current situation. And then we will have a short look on the electrode design process. Afterwards, I will present some of the tasks designers have to perform and which problems they are faced with. And after that, we will come to the section how we can help to solve these problems with Smart Electrode and some other tools. In contrast to previous Smart Electrode sessions, which offered a brief overview over the whole software, I will focus this time on the cooperation between different products from us. And finally, we will answer questions and finish with another survey. Okay, let's go on. At first, we would like to know which products you use. So for this, Christian will open a short survey.
Yeah, so here you go. I'll give you around about 30 seconds. Please take your answer and we will discuss the results afterwards. So 10 seconds to go. All right, and let's end this. So let's have a quick look at the results. So none or B&W partners are the most of you, and some have already used some products of us, like Expert Model Base, Extension, and Smart Electrode. So I hope you can learn something today. So Florian, let's head on.
Okay, perfect. Thank you for your feedback. And well, as I can see, we are a small group, so don't hesitate to ask your questions if you have some. I think we will have enough time to answer them. Well, at first, a short look on the process. So the process from article to mold was already shown in the previous webcast done by Sasha and Jan. And the electrode design process is usually located in the manufacturing department and starts with the mold data. And then you have, of course, to create an electrode assembly before you start with your electrode design. And you have to pass the data along to the CNC programming or computer-aided quality assurance, and finally transfer data to the programming system of the EDM. So let's have a look how Smart Electrode can help you to get the work done and how other products can be integrated in this process. At first, the electrode assembly. The task is we have to create an assembly from a mold created in expert mold-based extension. For this session, we will focus on a mold assembly from EMX, but normally you could also work with imported data. So the problems we are faced with is, in most cases, a modification of the original models is not allowed for the tool or electrode designer. In addition, we want to protect our electrodes from unwanted updating. This means regenerating in the background. And finally, sometimes it's helpful to remove unwanted geometry before extracting electrodes. So as a solution for this, we use a reference model in Smart Electrode. The options you have here are merged inheritance or copy geometry. And to freeze the electrode design, we can reset the electrode assembly to only update manually, so it won't regenerate automatically when the models in the background change. For the simplification task, we have a user interface called preparation, and this is what I'm going to show you in the first step. So we start with the assembly used in the previous session, learn how parameters and colors can work together. In this case, I will use the ejector side. So at first, we start with the assembly user interface and select the ejector side. As a reference method, we have the inheritance pre-selected here, and we just start the creation of the model. And now we have an independent, at the moment, independent reference model of our workpiece. And as a short check, we can have a look in our summary burn sheet. So we can see there's no dependency active at the moment. And let's go to the preparation user interface. In this case, as I mentioned before, we can use the data that comes along with expert mold-based extension. We can search for those features and get rid of them if we don't need them in the electrode assembly. So now it looks a little bit easier to work with, and that's the first thing I wanted to show, how to create a reference model with independent status. So let's come to the data exchange between different products. So we have the electrode assembly, and we would like to provide data for the downstream process. The problems we have here is the parameters are already available at the reference model, but we don't have any combined states, and we also don't have any color appearances at the moment. So what we need to do here is we need to extract that information again with Smart Update and Smart Color. So let's come back to this model. You can see we have Smart Color and Smart Update already available here in the top of the ribbon, the groups. I will open the reference model and start the check and updating process via Smart Update. So Sasha prepared a configuration which is working for the whole process from Smart Color over expert mold-based extension and inside Smart Electrode. So with pressing an active or activating the update button, Smart Update is going to extract the whole information, and it's going to create the combined states. the appearance states, and finally the annotations. So this process is finished. So what we can see here now is we have the tabs showing the different combined states. Currently, the manufacturing state is the active one, so this is the one we can later work with. We have another state for the visible surfaces and for the design changes. The first two tabs are called import because there's no access for the electrode designer. So this is only extracted information. There's no way to mess around in these combined states. So this has been shown, the whole stuff. Let's come to the task during electrode design. So there are many different things to do. At first, of course, we need to extract the electrode contour. We need to add a blank from library with a fitting size. Depending on the requirements in the following process, we maybe also need a holder model if we have to get the position of that holder model. We need to transfer data to CAM programming, maybe as step or IGES file, or the programming is done directly in Creo NC, maybe using the templates integrated in Smart Electrode. Drawings as documentation of the electrode positions are still in use in many companies. So at the moment, you cannot get rid of those documentations by the means of model-based definition approaches. Maybe you also have to provide data for computer added quality. So this may be just points, or maybe a color-coded 3D model. And in the end, we would like to pass information to the electrode programming system to simplify the programming and to avoid errors. In today's session, I will focus on the extraction of the electrode contour because we have a user interface to show how we could work with the extracted PMI. So the task is extract electrode contour. This means that the problems we may have here is we need to detect the regions or areas we would like to manufacture, and we have to decide or evaluate the surface quality we would like to achieve. So the solution for this is we again evaluate the provided color and parameter information from Smart Color and using Smart Update. And inside Smart Electrode, we have a new user interface called Topology, which helps you to group the surfaces as regions. You can directly work with those regions. And if some surfaces are used or edited in the user interface, they can also be hidden. So let's come to the next part of the live demonstration. This time, I will use the injector side as a start model. So let's come back here, load this model. We have to extract the data again after we created an electrode assembly. So at first I select the injector side and create create the reference model again using the inheritance feature. And I think most of Smart Electrode users may know if we are starting this electrode assembly from another assembly, we can come back to the assembly definition and maybe add another model to our assembly definition. So now I added the core model. If both models have to manufacture together, and I press OK, and the reference model is updated then. So you can see we have two inheritance models here now. And this is the complete model we are going to use for the electrode extraction. And let's go back to the reference model again to read the information provided by Smart Color again. So again, all the information is extracted and we get the combined states and the color appearances. And after that, we will have a look what we can do inside the new user interface. So let's go back to the electrode assembly. We need to add an origin for the electrodes at first, and now we can start the first electrode model. And here you can see we have the user interface, and when I open this, all different colors are summarized in this tree view, and you can go through the whole definition. And if you open one of the nodes, you can see that the surfaces are grouped. So all the connected surfaces form a region, and now we can process those surfaces if we want to. We also can select a surface directly from the model, and in the other direction, the software is going to select the correct region in the user interface. So if I pick this surface, you see it's going to be this region with 113 surfaces. And now let's have a look how this can help you to start the electrode design. So let's select this region or this color. This consists of 4 separate regions with only one surface each. So we can select the whole color and then decide to start the geometry extraction with standard values. So we will get one small body for each surface. Let's start this, and if we hide the work pieces, you can see we have those 4 small areas where we can start detailing now, or we can merge all these regions together and add just a single cutout for this. In this case, we will get the user interface as an additional information, and we can also change the dimensions of this cutout, and if we press OK, you will get the body and the cutout. I'll delete these features again. So as every electrode model can be redefined if you want to. So let's select a region by color with this part of the B&W logo, and we would like to add a single cutout for this. Let's have a look here in the wireframe view, and we would like to change the dimensions just a little bit and add the geometry. So now we can start the detailing of this geometry. And here we go. Just as an example, we used this contour. Now we can go back to the electrode assembly and maybe add another electrode model. Let's take those surfaces again. And what I now would like to show you is if you want to detail the current selections a little bit more, you can add the selected nodes to your current selection buffer. So you can close the user interface, and if you want to add more surfaces to the selection or deselect some surfaces, so you can redefine this through the whole process. And you can also remove processed items from the list. So if I now select this 4 surfaces and create the separate cutouts again, you can see that this node will be removed from the user interface. So this is also one solution to get the work done or to see what work has been done already. Okay, so this is what we can actually do with the color information. And let's jump back to the slides. Let's have now a look on a different task in electrode design. Design changes are some kind of daily business for the electrode designers, and every design change has an impact on the entire data created in the follow-up process. So this means the whole data has to be checked and updated. So we have a design change in the article. This means it has to be updated in the mold, and then all the data in the following steps has also to be checked and updated. So what can we do with those PMI information to help the designer? So the task is we need to recognize changed areas and we need to update the design. But electrode assemblies can be confusing if you have a lot of electrodes and all of the models interfere. And even if you update the model, you will have or may have lost references and therefore failed features you have to fix. So what can you do about this? As a solution, you can control the dependency of the electrode models in the burn list. And you can, in the first step, update the color information with smart color and then check the interfered or affected electrodes and then carry out the adjustments. So let's go back to Creo again. I prepared another small example. So currently we have an independent reference model and a dependent electrode model. So what I'm now doing is I'll set the electrode model independent and activate dependency for the reference model again. So let's go to the reference assembly and update the assembly. So now we have the first failed feature. This is currently the node from the annotations from Smart Color, but this is no problem. We are going back to the reference model and start the update process again. And then we will have a look what happened in that model. So the update is finished completely. So we have our manufacturing combined state, but the more important state is the revision at the moment. So you can see in the green revision 1 is the original contour, and the yellow colored faces are the design change which has been done in the article and in the mold. So we go back to the electrode assembly and we generate here. And if we change to the wireframe view, we can see here the changed contour of the workpiece, and the electrode itself didn't change so far. So we have two different options here. We can activate the electrode directly and regenerate it, or we can do that step by step. So in this case, I create a copy of that electrode model at first. And then I'm going to the burn sheet, and to create the updated contour, I just activate the dependency again and start the regeneration. So here we also have a design or a failed feature we have to check. In this case, it's the selected burn faces. Burn faces the designer selected. That's not a big problem because the whole model is built without usage of those surface references at the moment. So we can jump over that error for now. But let's check what happened here. We can see down here is still an area not filling the whole contour. So we need to adjust our solid. So let's get it here inside, and let's change the dimensions dynamically. So we pull that a little bit down, and it's okay again. Press OK. We may have to change the offset feature. So that there may still be some small contour we have to fix. Doesn't look like. So let's create a new feature here. Delete that, and finally add the base again. So this is, as an example, the updating of an electrode model. And now we can go back to the burn sheet, and maybe we would like to add a comment. So let's open the parameters here, and let's write as a comment, this is original. And this one, and this one is revision 2. So now we can also have this comment on the drawing and pass it to the guy at the machine. Okay, so far about the updating and what we can do with the colors here. Coming to the end, I would like to summarize what we have seen. So this is a process to pass PMI information through the whole process from article to electrode design using some of our tools. So it's not just a smart electrode alone. It's a whole process from smart color to smart electrode. And I hope it was interesting for you. So if you would like to contact us or stay in touch with us, you can subscribe to our newsletter or to our YouTube channel. where we offer new videos for new features regularly. And if you have more detailed questions, don't hesitate to contact us directly or ask for a demo license if you would like to check out for yourself. So thank you for your attention. And before I pass the word back to Christian, a short survey will follow after the meeting, and you will also receive an email with the screen recording. So thank you again, and Christian, it's your turn.
All right. Thank you, Florian, for your extraordinary presentation. Now let's go to the Q&A session. Right now, I haven't received any questions. If you have any questions on mind, I'll give you around about a minute to tell them to us. Just use the functionality of the GoToWebinar, and then we can talk about it. If you have any questions. If not, then it's all right. Yeah, also I would like to mention, as Florian said, after the webinar, there will be a survey. I would like to ask you to participate on it so that we can improve our webinar and also improve our product. So, no questions yet. 30 seconds to go. All right, then, no questions. Well, then I would thank you for your participation, and I hope you learned something new, and I hope you liked it. So have a nice day, and goodbye.